number 3, our example is that we have a random sample of 80 lawyers, and we asked these 80 lawyers whether they are in favor of capital punishment or if they're opposed to it. And we tallied up if they were male and female, whether they favored it or opposed capital punishment, and tallied up the responses. And now for this question, we want to find probability that a random lawyer selected from this group is any one of these things. So the first thing I want to do, the first thing I always do when I am given a table like this and I'm asked to find probabilities, this is called a contingency table, by the way. First thing I do when I'm given a table like this is I write out the row totals and the column totals, kind of just like we did when we did a chi-square test. So let me draw some lines and let's tally up the rows and columns. Okay, so the total number of people who favored capital punishment is 32 plus 13, which is 45. Total number of people who opposed capital punishment in our sample was 35. Okay, and the total number of males is 32 plus 24, which is 56. Total number of female lawyers was 13 plus 11, 24. So then our grand total is 56 plus 24, which is 80. We had 80 lawyers. Perfect. All right, so now for part A, we want to find the probability that a random lawyer selected from this group favors capital punishment. Well, how many total people in our group favored capital punishment? 45 of them. And how many people were in our sample total? 80. So 45 out of 80 people favored capital punishment. So the probability that any random lawyer favors capital punishment is 45 over 80. Okay. Part B asks, what's the probability that a lawyer from our group is female? Well, there were 24 total women out of 80 total lawyers in our sample, so that probability is 24 out of 80. Nice. Okay, now we get a little more complicated. What's the probability that a random lawyer is female and favors capital punishment? Well, we take the same approach as we did before. How many lawyers in our sample were female and favored capital punishment? There were exactly 13. 13 lawyers who were both female and favored capital punishment out of 80 total. So that probability is 13 out of 80. All right. Now we get a little more complicated. What is the probability that a random lawyer opposes capital punishment or is male? Keep in mind this or. So now, how many opposed capital punishment? 35. How many were male? 56. Well, remember when I take an or probability, a union, I don't want to double count anyone who's in both groups, right? So this probability is the probability of opposing capital punishment plus the probability of being male minus those people I double counted, the people who are in both groups, and that's that 24 people. So 35 plus 56 minus 24. Let's see, that's a lot of math. 35 plus 56 minus 24 is 67 out of 80. So there were 67 people who were in either of these two groups out of 80 total. This, if you like to think about it in terms of probability axioms, the probability of the union of any two events, remember, is the probability of the first event plus the probability of the second event minus the probability of their intersection. And that's exactly what I just did here. Okay, now we step it up a bit. Now we're talking about conditional probability. Given that a lawyer is female, what's the probability that they oppose capital punishment? Anytime I see the word given, I know that my denominator will be different. In other words, I'm only looking at female lawyers. So among female lawyers, how many of them oppose capital punishment? Well, first of all, I said my denominator will be different anytime I see this word given. So how many female lawyers were there? Well, there were 24 total. So my denominator will be 24. And among the 24 women, how many of them oppose capital punishment? Exactly 11. So the probability that a lawyer opposes capital punishment, given that they're female, is 11 out of 24. Now let's answer a similar question. What's the probability that a lawyer is male, given that they favor capital punishment? So now among the lawyers that favor capital punishment, so among these 45, how many of them were male? What's the probability that, given that you favor capital punishment, you're male? So there are 45 total lawyers who favored capital punishment. Among those 45, 32 were male. Lastly, are these two events, being male and favoring capital punishment, independent? Let's talk about that for a second. Events A and B are independent if, and we have two tests of independence. So we can say A and B are independent if the conditional probability, if A given B, doesn't depend on B, right? Two events are independent if the probability of A given B doesn't depend on B at all. It's just equal to the probability of A. Another test for independence that we have is seeing if the probability of A and B is just equal to the probability, or the product of those two probabilities. So in other words, to answer if the events male and favoring capital punishment are independent, we just have to test if one of these two properties is true. So in other words, I want to test if probability of male, given that you favor capital punishment, is equal to the probability of being male. If this is true, then we say that these two events are independent. So let's see. Well, luckily, conveniently for us, probability that you're male, given that you favor capital punishment, is exactly what we calculated in part F. And we found that was 32 out of 45. So now let's see if that's equal to the probability of being male. Probability of being male or why don't I write it like this? Probability that you're male, given that you favor capital punishment, 32 out of 45. Probability that you're male, let's see. How many males were there? There were 56 men out of 80 total. So the probability that you're male is 56 out of 80. So let's see, are these two probabilities equal? Let's see, so 32 out of 45, if I convert that to a decimal, it's 0.711. If I convert 56 out of 80 to a decimal, this is 0.7. Well, these two are not exactly equal. So we say these two events are not independent. The probability that you're male, given that you favor capital punishment, is not equal to the probability of just being male. In other words, this property is false, so therefore these two events are not independent.